Hello and welcome. I am Leo Alvarado, and in this video, we will going to cover how to automate and codify your Exadata Database Service deployments using OCI Resource Manager and Terraform. Then in the demo, I will demonstrate how to discover resources and generate a baseline Terraform config from an existing Exadata Database Service on dedicated infrastructure environment using OCI Resource Manager, how to codify and update the Terraform config, and how to rebuild the existing infrastructure in a new region and compartment. Let's start by opening your OCI console and navigate to your existing Exadata Database Service environment. Here we can see an existing Exadata Cloud infrastructure X8M-2 running on Frankfurt region under the compartment name Interconnect. Then inside the Exadata Cloud infrastructure is a cloud VM cluster with 4 OCPUs enabled. Inside the VM cluster is an Exadata database provisioned in the database home with the 19C version and with one pluggable database. What we are going to do here is to discover the existing Exadata Database Service environment resources using OCI Resource Manager, which is a managed Terraform as a service in Oracle Cloud, by creating a stack from the existing compartment. Using this feature, you can generate a baseline Terraform configuration and state files that you can use to codify your infrastructure using Terraform and OCI Resource Manager. And by creating the Terraform configuration files, you can codify and recreate your existing infrastructure architecture in a new tenancy or region. And as your infrastructure grows in scale and complexity, it becomes evident that it will be better to manage it programmatically. Let's start on discovering our existing Exadata Database Service on dedicated infrastructure environment resources. For this demo, we will be recreating and codifying the existing Exadata Database Service infrastructure to our new target region and compartment, which is in London. That will be used as our development environment under the compartment name interconnect_development_test. Using resource discovery, let's create a stack from our source compartment. On your console, click Developer Services. Under the Resource Manager, click Stacks. Click Create Stack. In Create Stack page, select the option Existing Compartment as we want to generate a Terraform config from a source compartment. Select Interconnect for the compartment. Select Frankfurt for the region. Filter for specific services. Select Core and Database Services as we will be capturing the network and Exadata Database Service resources. Enter a name for the stack. Add a description, which is our exported Terraform config that will be used for development environment in London. Select the compartment where you want to create the stack. Then click Next. In the Review panel, verify your stack configuration. Check for the source region and compartment. Then click Create. When the work request finishes, a job runs to generate a Terraform config file for the stack. Then when the job finishes, the resources in the selected compartment are captured in the generated configuration. Click on Download Terraform configuration and save it for later editing. Now that we have discovered and captured the resources, next is to unzip the baseline Terraform config that we just downloaded and edit it as required on a text editor. The config file contains the services we selected. In the core.tf, you can find the discovered network resources such as the virtual cloud network and its components. In the database.tf, you can find all the discovered cloud database services resources on the source compartment, such as your Exadata Cloud infrastructure, VM cluster, database home, and databases. Now let's edit our baseline Terraform config file as required. In the core.tf, make sure we define all the network components we require for our new Exadata Database Service environment, such as the virtual cloud network, the client subnet, the backup subnet, and other components such as internet gateway, routing table, security lists, network security groups, and others. You can make use of the discovered networking objects in the baseline config we have generated. In the database.tf, make sure we have all the required resources to create an Exadata Database Service. First is to create and define the OCI Database Cloud Exadata Infrastructure resource. Make sure we have the correct values for the arguments defined in our Terraform config, such as the availability domain, compartment ID, compute count or database servers count, display name, maintenance window, shape, and storage servers count. Next is to create and define the OCI Database Cloud VM cluster. Backup subnet refers to the OCID of the backup network subnet associated with the cloud VM cluster. The Cloud Exadata Infrastructure ID refers to the OCID of the Cloud Exadata Infrastructure resource. Define the cluster name. Compartment ID refers to the OCID of the compartment. CPU core count refers to the number of CPU cores to enable for Cloud VM cluster. Provide a display name. Domain refers to the domain name used for the Cloud VM cluster. Provide a valid Oracle Grid Infrastructure software version. Provide the host name for the Cloud VM cluster. Local backup enabled. If true, database backup on local Exadata storage is configured for the Cloud VM cluster. Sparse disk group enabled. If true, the sparse disk group is configured for the Cloud VM cluster. Provide the license model. Provide the OCPU count. Provide the TCP and TCPS scan listener port. Define the public key portion used for SSH access to the Cloud VM cluster. Define the OCID of the subnet associated with the Cloud VM cluster. Now let's define and create the database home. Provide the database home version. Provide the display name. For the source, you need to use the value VM_cluster_new for creating a database for a VM cluster. VM cluster ID is required when source is equals to VM_cluster_new. This refers to the OCID of the VM cluster. Now let's define and create the database. We need to define the resource OCI_database_database. Provide the admin password. Define the character set. Define the DB name, DB unique name, DB workload type. Provide the end character set. Provide the PDB name. Provide the SID prefix. For the DB home_ID, this refers to the OCID of the database home. In addition to our dev PDB, we will be creating additional 2 PDBs, one for SIT and one for UAT. Value must be OCI for the provider. Edit the vars.tf file to specify the destination compartment ID and region. You can find the compartment ID under the compartment details on your console. After updating the Terraform config file, we can now proceed and rebuild the Exadata Database Service infrastructure to our new development environment, which resides on a new region in London and new compartment named interconnect_development_test. Let's create the new stack using the edited configuration file. Open the navigation menu, click Developer Services. Under Resource Manager, click Stacks. Click Create Stack. In the Create Stack dialog, click My Configuration. Add the Terraform configuration zip file that contains the Terraform config that we just updated. Provide the name and description. This will be our Terraform config to be deployed in the dev environment in London. Click on Next. Double-check on the values of the variables that we define. Click Next to display the review panel, then click Create to create our new stack. Now that we have created the stack, let's run a plan job. Running a plan job parses your Terraform configuration and converts it into an execution plan, listing all the resources and actions that will result when an apply job is run. Click Plan, provide the name, then click Plan. The new plan job is listed under Jobs with an initial state of accepted. Soon the status changes to in progress. When the job is complete, you can review the execution plan. Here we can see the following actions Terraform will perform, starting from creating the virtual cloud network, virtual cloud components, Exadata Database Service resources, like the Exadata Cloud Infra, Cloud VM Cluster, Database, Database Home, and pluggable databases. After a successful plan, let's now run the apply job. When you run an apply job for a stack, Terraform creates the resources and executes the actions defined in your Terraform configuration. Click on Apply. The new apply job is listed under Jobs, and status changes to in progress. Here we can see that the Terraform is creating the virtual cloud network and other network components. Once completed, it now proceeds on creating the Exadata Cloud infrastructure. Once done, it will now create the Cloud VM cluster. Checking the console, we can see the created virtual cloud network and its components. We can also see the VM cluster provisioning is ongoing, and the created Exadata Cloud infrastructure which shows the status of updating. After our VM cluster has been created successfully, it will now proceed on creating our database. You can see that the database home has been created, as well as our dev pluggable database. Then it will proceed to create the SIT pluggable database, then to be followed by the UAT pluggable database. Monitor the log status until it shows the apply complete and validate in the logs that all resources has been applied. Apply job status changes to succeeded. This indicates that the job has been completed. After it completes, you can download its log file. From the console, let's now check the new Exadata Database Service infrastructure that we have created using Terraform and Resource Manager. Under the networking, you can see the created virtual cloud network and its components. For the Exadata Database Service resources, we can now see the created Exadata Cloud Infrastructure X8M-2 model, the Cloud VM cluster with 4 OCPUs enabled, our development database which is provisioned using the database home with the 19C version, with the 3 pluggable databases, one for UAT PDB, one for SIT PDB, and one for Dev PDB. Congratulations! We have codify and automate the deployment of your Exadata database service. And now we can move from a manually managed infrastructure to an infrastructure managed with automation.